Good afternoon, everyone. My name is Uma Maheshwari. I am here to discuss about the topic of serial communication. Here, the serial communication in general, it is a method of transmitting data from one bit to another bit, that is at a time over a single communication channel or a wire, or unlike the parallel communication, whatever it is, parallel things. This process uses, definitely a protocol is being needed for this, right? So the protocols like RS-232, USB, these are all the things to ensure the reliable and secure data exchanges between two stations. Like the transmitter will be in one side and another side will be your receiving point. Got it? The next thing is how it has been working. It is a bit by bit transmission. First one is it is there, and the second one is through protocols, and third one is the components, what are all the things it has been needed for this one, and the data frames, etc. Here bit by bit transmission is, here the data is broken down into individual bits and sent sequentially over a single channel. The protocols is a thing. The serial communication relies on the strict protocols to manage the transmission and reception of data, ensuring the reliability and it also to prevent the errors it has been happening over there. The next thing is the components. The components is nothing but it involves a serial interface or a serial port that could handle a serial data between a central processing unit, that is in CPU, and also in the peripheral devices. Fine. The next one is the data frames. Here the data is sent in a data frames after a start bit, signal, and beginning of the messages, and an optional parity bit to include for error handling things. The next one is the mode of transmission. What are all the things it should do? It We can say like it is a simplex, half duplex, full duplex, etc. Here the simplex is nothing but the communication flows in only one direction, like an one-way radio broadcasting. And the next one is the half duplex. It can send at both sender and the receiver. It can transmit and then receive the data, but not at the same time. Here in this case, the full duplex is also there. It is allows both sender and the receiver to send and receive data simultaneously. Examples and application is, it is a wired connection, embedded systems, and then computer connection. The wired connection is nothing but the modern devices like webcams using USB, even digital video signals using ports like HD, STI, and then it utilizes the serial communication and all. It's there. And the embedded system is the microcontrollers or embedded systems use the serial interfaces like SPI and I2C to communicate with sensors and other peripheral devices. Got it. The next one is the computer connection. Early, we have handled the computers like RS-232 to connect to the device like modems, and it remains a fundamental method in various industrial applications. Here, the next one is transmission. Like so far, we have seen that transmit, status, and then control register. In this, it is a control register of a serial communication module like PIC microcontroller USART that manages the data transmission. That is, it will be always in the transmitting end. Here, the transmit enables, it enables the serial ports transmitter. The synchronous asynchronous mode, it selects the communication mode for both transmit and receive operations. And the high baud rate is, it selects whether to use a high or low baud rate. And the 9-bit transmitted, it enables 9-bit transmission where the 9th bit can be used as a parity bit. The 9th transmit data bit is, it contains the 9th bit, it can be used as a parity one. As I have told you, like so far we have seen the transmission thing. At the receiving end, this slide it shows that the receive status and then control register. How it is being used, this receive status and then control register. Here the receive status and the control register, it is also an 8-bit thing. Even it can handle up to 16-bit. It is a 8-bit register in PIC microcontroller. It used to configure and control the USART receiver module for serial communication. It also enables and disables the thing. And it contains a status flags like an overrun error bit. Key bits include serial port enable and to enable or disable. Here, the key functions of this RCSTA, this is also a register I told you in the receiving end. The serial port enablers, it setting this bit to 1, it enables the module to configure the RX or DXT as an input. Here it can also handle up to continuous receiving enable. That is CREN is the most important one. Here I can show here. The fourth bit is the CREN. This one is setting this bit to 1. It continuously enables the receiver to receiving data. Clearing, it stops the receiver. The ninth or eighth bit reception is RX9 is equal to 1 means it enables ninth reception, and if it is 0 means it is a receiving side, it stops the receiver. Got it? And the next one is next is the next function, that is the next slide shows the SPBRG. This SPBRG register is the one. It is used to micro. It is used in microcontrollers like PICs to send the baud rate. That is to set the baud rate. The baud rate level is most important one in the case of serial communication. So it is by storing a value that determines the period of the time, that is the value loaded into SPBRG is calculated using the system's oscillators frequency, and it is also a desired baud rate. And the function and the calculation is based on the thing, that is based on the communication, that is based on the baud rate you are just setting. This function, that is it is this register counter that generates the clock signal for USART module. The next one is UART communication with the PIC. This system, this 8-bit shift register shows that this animation shows that how the clock and then data input is being storing in this one. So this slide gives you a clear explanation how a data bit is transferring from one bit to another in the case of serial communication. Fine. The next one is RS232 to USB converter. This RS232, communication part is also, that is this animation is also shows how the data has been receiving. This is a form of USART communication. This is an example of this PIC microcontroller and how the transmitter is acting as a master and the receiver is acting as a slave. Let us summarize this one. Here we have discussed about the transmitter and the receiving end and the baud rate, why it has been very important for setting anything. And this is the classroom activity. These are all the assessment questions. Which SFR is used for setting the baud rate? In the name itself, you can see like TX and RC is the transmitting and then receiving one. So SBBRG is the only most important one for setting the baud rate. And simultaneously the flag bit register indicates which one, and which of the following register controls or enables the disable the USART method, and the purpose of the baud rate CON register, which one is for use. This is all the references I have taken. So thank you. We'll see the next topic in the next video.